Section 10.4 is on the inverse of a function. For your learning targets, you will be able to find the inverse of relations, be able to explore inverse functions, find inverse functions algebraically, and find inverses of nonlinear functions. So example 1 is finding the inverse of a relation. And so to find the inverse, you basically just switch the x and the y values. So our new points here are going to become 6, -2, 5, 1, 4, 4, 3, 7, and 2, 10. So again, you're just switching the x and the y values. So the same thing when you're given the information in the table, your input is like your x and your output is like your y. So we're just switching those values as well. So we're going to have 2, 0, 4, 2, 6, 4, 8, 4, 10, 2, and 12, 0. So again, we're just switching the input and the output, just like we switched the x and the y. So for example 2, you're writing a formula for the input of a function. And so first we're going to take the f of x equation and solve y for y equals f of x for x. So we're going to replace this f of x with y. So we have y equals 3x minus 5, and then we want to solve this equation for x. So we're going to add the 5 to both sides. So we have y plus 5 is equal to 3x. And then to get the x by itself, we're going to divide both sides by 3. So we have y plus 5 over 3 is equal to x. And I'm going to rewrite it just so it's in x equals form. So x equals y plus 5 over 3. So this is the first answer. So then it wants us to evaluate the input when the output is 4. So that means like your y value. Evaluate this when y is 4. So we have x equals 4 plus 5 over 3. So 4 plus 5 gives us 9. And then 9 divided by 3 is 3. So our second answer is x equals 3. So for example 3, you're finding the inverse of a linear function. And so again, we're going to start by replacing that f of x with y. So we have y equals 3x plus 4. So then from here, to find the inverse function, we're going to switch the x and the y. So I'm going to rewrite this exact same thing and just switch the x and the y in their place. So I have x equals 3y plus 4. And now we're going to work on solving this equation for y. So I'm going to subtract the 4 from both sides. So I have x minus 4 is equal to 3y. And then I can divide both sides by 3, or I can divide each term by 3. I like dividing each term by 3 because then we end up getting a linear function in standard form, or in graphing form, y equals mx plus b. So there's like a 1 in front of this x here, so I'm going to write 1/3 x minus 4 over 3 is equal to y. And then I'm going to rewrite this so the y is on the left, and then we're going to rename y g of x for our inverse function. So we have g of x equals 1/3 x minus 4 over 3. And this is going to be our final answer here. Okay, example 4 is finding the inverse of a quadratic function. So it says find the inverse of f of x equals 1/2 x squared for x is greater than or equal to 0, and then graph the function and its inverse. So first we're actually just going to start by graphing the function. And it's saying that x is greater than or equal to 0. So I'm going to start my table at 0 and then plug in these points into this equation. So 0 squared is 0. 0 times 1/2 is 0. 1 squared is 1. 1 times 1/2 is 1/2. 2 squared is 4. 1/2 times 4 is 2. 3 squared is 9. 9 times 1/2 is 4.5. And 4 squared is 16. Half of 16 is going to be 8. So we're going to graph this original function first. So here's our graph of f of x. So to graph the inverse, we're just flipping these points around. So we're going to make this side the x and this side the y to graph the inverse points. So here's our graph of the inverse, and I've labeled it g of x. So now let's find the inverse function. So again, we're going to rewrite this, replacing the f of x with y. And then to find the inverse function, we swap the x and the y. So we have x equals 1/2 y squared. So now we want to solve this for y. So first we're going to move the 1/2 by multiplying both sides by 2. So we have 2x is equal to y squared because 2 times 1/2 is 1. And then now we're going to square root both sides. So when we square root both sides and we're solving, we have to do that plus minus on the opposite side. So I have the plus minus square root of 2x is equal to y. So now I don't have this negative portion down here of the graph. I only have the positive portion. So when we write our answer, we're just going to keep the positive part of g of x. So we're going to say g of x is equal to positive square root of 2x. And this is our inverse function. So for example 5, we're finding the inverse of a radical function again. So we have f of x is equal to the square root of x minus 3. So it says determine whether the inverse of f is a function and then find the inverse. So your square root graph is kind of like that halfway or half of like a sideways parabola. And so the inverse is going to be like half of a regular parabola. Okay, so your square root graph kind of looks like this. And so the inverse of that is going to be something that kind of looks like this. And so the inverse is a function. So now we're going to go ahead and work on finding the inverse. So we have y equals the square root of x minus 3. And we're going to swap the x and the y. So we have x equals the square root of y minus 3. And we want to work on solving this for y. So to get rid of the square root, we need to square both sides. So we have x squared is equal to y minus 3, and then add the 3 over. So we have x squared plus 3 is equal to y. So that gives us g of x is equal to x squared plus 3. So now this would graph a whole parabola, but that's not what we want to graph. So we want to be able to graph just the portion of it that's going to be the inverse of the square root. So if you go back and look at the square root function, our starting point of the original function was at 3, 0. So if we flip that point around, that gives us 0, 3. So that means that the starting point for this function is going to be when x is 0. So we want to say that we want this function, but only for when x is greater than or equal to 0. And that's our answer for this problem.